I'm going to show you how to verify linear curve fitting, and I'm assuming that you watched the previous videos, and if you haven't, some of this might not make too much sense. Okay, so let's look at example 1 in the previous video. We were given the equation y squared equals ax squared minus b, and we decided to get a linear plot. You would plot the values y squared versus x squared, and the slope would be a, and the intercept would be negative b. Alright, and we want to verify this. And where do we start? Okay, so first I'd say start by solving for y. Okay, and to do that you just take the square root of both sides and you'd get the square root of the right hand side. So y equals the square root of a x squared minus b. And what we're going to do is eventually write this out and assign this value to y, but first we must assign values of a, x, and b. Okay, so let's assign those values. X, what we'll do is create an x vector in our desired range. -5 to 5 is usually a good bet. And then I'll add a note in here. Assign x vector. And then under here, we will be assigning appropriate constant values. Okay, and what I mean by appropriate is if you look in here, this is why we solve for y, we see that we want to avoid imaginary numbers, so you're going to want ax squared minus b to be positive values. So let's make a equal to 3 and b equal to -7, because when we subtract a negative value we'll get a positive value. And also it'd be a good idea to suppress these. Okay, and now we can actually type in what we solve for y. So y equals square root of a times x squared minus b. Okay, and at this point I would recommend creating subplots to view multiple plots at the same time. And it'll become a little more clear while we're doing this. Okay, and remember, ultimately we want a straight line. Okay, so the subplot command gives us multiple plots, and the first entry, you're going to have rows by columns. So 2 by 2 will be creating 2 by 2 matrix of plots. And then, so the first entry is rows, then columns, and then the third entry is going to be which plot we're creating. So it'll be the first plot. So then below, let's just say you want to look at the plot of y versus x for reference. So let's run that. And this is what we get. Notice we have these in the command window, so you're going to want to suppress a command to avoid that. And you see that this is not linear, so let's try some other things. So suppress that. So for the second plot, let's just say you and some friends are arguing about what do you have to plot to get a straight line, and someone says you have to plot y versus x squared, and that'll give you the linear plot. And let's find out if they're right. No, we still do not have a linear plot. Let's try again. So another friend of yours is almost certain you have to plot y squared versus x, and that'll give the linear plot. And you're not quite convinced, so you want to verify this for yourself. Nope, that is not linear either. None of these have been linear. So then you come in and you say, I've had enough of these games. Let's plot. Well, first let's create our subplot. 2 by 2's dimensions, the fourth entry, fourth and final. You say, let's plot y squared versus x squared. And I guarantee this is going to be linear. Oh my gosh, you're right. It is linear. That is what we wanted. Alright. And then after this, I'd recommend typing in figure to get a separate figure of the plot that is linear by itself. So let's do that. Okay, so we have our two figures. We can delete our previous one. And we want to just look at this figure and enlarge it. Okay, so first we want to verify the Y-intercept is what it's supposed to be. So take the zoom in, the plus magnifying glass, and zoom in as far as you can for x equals 0 to find the Y-intercept. And I'd say do this 5 to 10 times to really get an accurate value. Okay, so it looks like it's about 7, so you can take the data cursor, click right here, 0, 7. So our plus b value should be 7. Okay, let's check it out. What we predicted, we said that our slope would be a and our intercept would be negative b, and we assigned the b value of negative 7. So the negative of negative 7 is 7, which we got here. So that is correct. So now we just have to verify that the slope is equal to a, which we assigned the value of 3. So I'll put a note of what we just did. Verify intercept with data cursor at x equals 0. And the next step is to verify the slope with the relationship y2 minus y1 divided by x2 minus x1. So basically, we're going to be taking 2 points on this plot here. Going to be selecting 2 points and finding the slope and seeing if that matches our assigned value, which it should. So you're going to want to take this plot. I'd recommend clicking on the magnifying glass, right clicking, and reset to the original view, and then that'll make it easier for the data cursor. So we have one of our points, 0, 7, so we can start to fill that in the command window. We have we want to get y2 minus y1 over x2 minus x1. So we have our y1 value is 7, and our x1 value is just 0. So let's pick another point further along here. The data cursor tool. Drag this down. Okay, let's pick this point. So this is our y2 and x2, and we can plug in these values. We have a y2 of 67.61 and an x2 of 20.2. And once we take y2 minus y1 over x2 minus x1, we'll get about, that looks like about 3. Okay, and what did we say earlier? We said the intercept would be, the slope would be a, which we assigned the value of 3. So that's awesome. We just saw that we can verify our result just by using MATLAB, and that is pretty impressive, I'd say. So hopefully you found this helpful, and if so, leave a comment below or check out the other videos. Thanks for watching.